Hello, this is our assignment 7 for machine learning. Our group is consist of Ina, Yestina, and me, Yohao. And I will present first. First, we need to prepare our data. So how we can get the data by this link, and the image above shows we have two CVS file, which is tracks and artists. After get all data we need, and to be sure if we can trust this dataset, it is important to check if there are any values are missing. So we use its null function, and as a result set, it's just 71 missing value in the dataset. Consisting in this dataset consisting of over 5,000 key rows. So I mean, it is not too bad. So we can using it, and it will be valid. And the release date column, we just the data in release date column is in data type, and then when we just put the mouse years into a separate column for the coming analysis. Also, we changed the unit of duration from the milliseconds to minutes. Okay. And our first question, how many tracks gained popularity over 90 out of 100? To check this, let's use a panda function query. This is a filter function that enables the selection that filters the columns of a data form with a Boolean expression. And this data form dot curd method only works if the column name doesn't have any empty space. So before applying the method, space in column names should be replaced by this lower dash. And here was the code. And for the coming questions, this is the second question. We are going to use query again, but this time we're going one step further and dealing with a bit more complex problem, since we have identified two additions, which is songs with popularity greater than or equal than 80. Second, the songs that released in March 2020. So here is the code showing.
For the next question, we explore the correlation between popularity and track traits. And first of all, we focus on the correlation between popularity of the song and how it's common to dance for the given song. And on the graph that is applied on the slide, we can see that the more popular a song is, the index of the danceability is higher, which means that the more popular a song is, the more common it is to dance to the song. Also, showing the correlation on the graph, we can also correlate two features by the Pearson R package that we imported. And we can see that the correlation between those two features is 0.899, which is quite good correlation, because if the index would be 0, it would mean that there's no correlation. So that's the other form of showing the correlation between the data. We also explored the correlation between the popularity of the song and instrumentalness, and we can see that it's exactly opposite to how it was between how popular a song is and the danceability feature, because here the more popular song is, the instrumentalness is lower, because the index, if the instrumentalness would have value 1, it would indicate that there are no words at all. And the lower the value is, the more words the song contains, which means that the song is more popular if the more words it contains. As it will be later explained, we can also check the correlation of any two given features by displaying that on the graph. As another question, we also analyzed how it changed over the years the duration of the songs in minutes. So we can see that it stayed like almost the same. Like there was some pattern that the duration increased a little bit of the over the years, but still it remained more or less the same ever since.
This question was an interesting one. What is the correlation between tracks' different features? Thanks to pandas and plotly, we can easily check the correlation between any two given features. Thanks to this method, correlation method, which helps us compute pairwise correlation between different columns of the dataset, and another method, heat map, which shows the magnitude of a phenomenon as color in 2 dimensions, we can see nicely correlation between two features. In order to see the graph, we had to import plotly library called graph objects. Here is that legend we just coded in the last slide. The graph shows us how the color gets lighter as the correlation increases. So if it's very bright from, let's say, 0.5 to 1, then the correlation is much bigger, and we can take it into consideration. We observe that there is no significant positive correlation between popularity and song's feature, for example. But what we can observe easily is that most positive correlation occurs between 4 features, which are popularity, danceability, loudness, and energy. This is the last question we were observing in this dataset, and it's who is currently most popular and what genres do they represent. So after standard importing of the dataset of the artists, we wanted to show analysis done on artists who is the most popular. And as we can see here, Justin Bieber, Taylor Swift, and Drake are taking the top list. Also in this code, we have put popularity based on its highness. So the higher popularity is going to show the first. What we did next was analysis on genres. So we imported genres, and then in order to do analysis on it, we had to remove the empty ones and then use this explode method to separate multiple genres of the same author into multiple genres, not showing a list of genres for one author. Explode function, what it does is splits the list by each item element and creates a new row for each of the elements. In this last slide, we are showing that we actually specified only 2 columns, genre and total count, in order to use matplot library pyplot to make a pie chart. We made this pie chart with only first 30 genres, and it can be shown which one is used most, which one is listened to most, which is obviously dance pop. And that's about it. Thank you so much for watching. Thank you from Justina, Juhau, and Ina.